In this video, I want to just review the basic transformations we've discussed in this unit and put them into practice. So, our basic transformations we've done were the translation, or the shift, the reflection, or the flip, and the dilation, or the stretch. In each case, we can either be horizontal or vertical. If we're horizontal, we always deal with the horizontal variable, or the x. If we're vertical, we deal with the vertical variable, which is the y. In all these cases, when we're transforming the graph, we're doing it by doing the opposite in the equation. And what we're going to do is we replace our variable. So we replace x with x minus h, and we replace y with y minus k. We replace x by x divided by a. Y divided by b. So we're always doing the opposite of what we'd expect, and we're replacing the variable or the input with, in the horizontal case, the output in the vertical case. Also, when we look at these, sometimes we call the transformation and the reflection, we call these rigid, because they do not change the basic shape. I mean, we do a mirror image, but we're just moving it around in the shift. We're not changing the look of it. But the dilation, as we stretch it, as we distort it, this we would refer to as non-rigid. That does a little bit more to that. When we put all of these together, we can make a kind of generalized form of our function. So if we started with y equals f of x, once we do all these transformations, we're going to end up with something that looks like y minus k all divided by b equals f of, I need a little more room here, make it smaller, x minus h divided by a. Now, you notice I didn't do anything about the reflection, because basically we can take this reflection and put it into the dilation factor. So if it's reflected, my dilation will be negative, and if it's not reflected, my dilation will be positive. Now, we like to look at this a little bit differently. It's a little more friendly if we solve for y. So we'll multiply by b, so we get b times f of x minus h over a, and then we add our k. But to make it even nicer, give me just a little bit more room, in most cases, we can look at a dilation. This dilation factor, we can often just use the vertical. And that's if my function, if my domain and range are going to all real numbers, or at least on one end goes to infinity, then we can make a horizontal reflection look like a vertical reflection. So we often don't worry about the a value, and we put all of the transformation in the b. There are some functions where we do have to consider them separately. But for the three families we've been working with, absolute value, square root, and square, we can figure that translation into there, and very often we can just look at this equation. B times f of x minus h plus k. And this makes it a whole lot easier when we are trying to either write the equation or graph an equation of a transformation. So let's do this. Let's go and try to put all of this together to write the equation of a transformed function. So I'll look at this function right here. Now, we're going to start off, as I keep saying, I always start with the parent function. So my parent here is y equals x squared. It does look like a parabola, so that's going to be our starting point. Now let's look and see what kind of transformations we have. For a parabola, I look at the vertex. The vertex is the point 310. So the vertex gives me my translations. So now I know I'm going to shift 3 right, and I'm going to go 10 up. So when I'm looking at my equation, right now I'm going to say y minus 10 equals, and I have x minus 3 squared. I look at this, I know I have a vertical reflection. So I know there's going to be some kind of a negative in front of it. But I also look and see, is this normally, can we come down in my 1, 3, 5, and say it doesn't match my undilated parabola? We know it's a dilation there. Now for me, often the easiest way to deal with this is I'm just going to say I have a vertical dilation, and the dilation factor is b. And I know that b has to be less than 0 because it has this vertical reflection. I'm going to put them together. Now, the easy way to find this is kind of like we did, well, or did we do this? I don't know. Is we have the value we have to find. So let's just use 1 point on the graph to help us find that. So I look at my graph, and I'm looking at this point right here. That's the point 1, 4. If I have the correct equation for this parabola, then 1, 4 will work in this equation. So let's just plug it in. So I'm going to say y, which is 4, minus 10 equals my b value times my x, which was 1, minus 3 squared. Let's give me a little bit more, get off here off the graph. So 4 minus 10 is a negative 6. And I have b times 1 minus 3 is a negative 2 squared. So a negative 6 equals b times 4. And I'll divide both sides by 4. And I get b is negative 1.5. And as I said earlier, there's a vertical reflection, so that b value has to be negative. Well, the b value is negative. That's what I expect. So that looks good. So we plug that into what we have up here, and I'm going to get the equation y, no, I don't want that. There we go. Y equals, no, not y equals, y minus 10 equals a negative 1.5 times x minus 3 squared, or y equals 1.5 times x minus 3 squared plus 10. Ta-da! So now let's go the other way. Let's start with an equation and see if we can draw the graph. Here's my equation. Y equals a negative 4 times the square root of the opposite of x plus 3. And then we're adding 7. So again, I'm just going to start by describing the transformations. Some will help me graph it, and some will help me double check to see that it looks reasonable. So I'm going to start, I'm there again, with the parent. I always start with the parent. Y equals the square root of x. It gives me an idea what I'm looking for. I'm going to look at my translations. I have a plus x plus 3, so this is going to be a left 3. I have plus 7 on the end, so I know that's going to go up 7. I look at my reflection. Wow, that's awful. Reflection. I can't write fast on this. I got a negative in front here, so we know we have a vertical. And I got a negative inside by my input, so I know I have both vertical and horizontal. So I know the parent says it kind of looks like that sideways parabola. Reflection vertical means I flip it vertical, horizontal, I flip it the other way. So my graph should look something like this. So we go down and to the left. It gives me an idea when I get my final graph, does it look reasonable? I look and I also see I have a dilation. I have a vertical dilation. Factor of 4. That means I'm stretching it, I'm making it much bigger than it would be. It would be taller. That's again a double check when I'm looking at my answer. But the translation is the thing that helps me get started first. Because the translation gives me my starting point. So I start left 3 and up 7. That's going to be my starting point. That also tells me to help me when I'm trying to find these other values. I know from this point it's going to go somewhere like this. But I can try to really rack my brains and try to fit that stretch into the patterns I found. Or I could just come along and make an XY table and plot some points in and see what I get. But this is also where this reflection helps me, because since I know it's going down and to the left, that means my domain is going to start basically here at -3 and go to more negative numbers. So the biggest number I can put in my table is a -3. And then I need to pick some numbers that are to the left of that or smaller. So I am going to make use of my 1, 3, 5 thing, because I'm going to say, what's going to make this an easy number to find the square root of? Because -3 plus 3 is 0. If I make this a -4, I'm going to get 1. I can take the square root of 1. I'll go to -7, go another 3 there, because -7 plus 3 is -4. Opposite of that makes it a +4. I can take a square root. You can do things like that. You can make it a little easier, or you just plug it into your calculator. Get the value you want. I like doing this because this will give me nicer points to plot. Let's just do one more. So from the 7, I went 1, I went 3, so I'm going to go 5, so a -12. I plug those into my function, and I will get at 3, I get 7, which is what I expected, because that's where I'm supposed to start. Looking good so far. At -4, I got 3. At -7, I got -1. At -12, I got -5. So I plot these points. -4, 3. -7, we're at -1. 5, 6, 7, 1. And at -12, we're at -5. 11, 12. So my graph looks like that. And now I just double check it. It does look like I expected. It's a vertical reflection. It's a horizontal reflection. It's that square root. It's that sideways parabola shape. It's starting at -3, 7.